studied last time, yesterday. And so yung mga basic type of series natin or series circuits natin and its equivalent impedance expression in the complex number format. So if we have a resistor, yung equivalent impedance natin is R. Then if you have an inductor, so that is JXL, wherein yung XL natin or the inductive reactance is equal to 2 pi FL or omega L. Then for our capacitive reactance or capacitor, we have negative J X sub C for the capacitive reactance wherein X sub C is equal to 1 over 2 pi FL or 1 over omega C. Then the combination of our resistor and inductor, resistor capacitor, an inductor and a capacitor, and yung series RLC circuit are given as ito. So kapag series RL, so we have R plus JXL. Kapag series RC, R minus JXC. Then kapag series LC naman, so whichever is higher, so yun yung magiging sign ng ating impedance. Then, same with the series RLC. Yeah. Now, so, paano naman daw kapag ang ating circuit are connected in parallel? So, if we have here um, the voltage source, yung source natin, so of course, yung current natin na dadaan dyan, yung total current natin, yan. Pagdating niya dito sa node na to, pagdating ng current dito sa node na ito, maghihiwalay na yan. So, there will be I1. Tapos, since isang node lang naman are, yan. So, magkakaroon ng I2 dito sa branch na to, or dito sa impedance na to, at saka dito. And so, since ang ating voltage or total voltage ay constant, since this is a parallel connection, and so we will graph our voltage dito sa ating x-axis. Then, so yung I3 natin, ang sabi nga natin, um, the current and the voltage for a resistive circuit, purely resistive circuit, is in phase with the voltage. So, kaya nandito din si ating, yan. So, nandito din yung ating current for the branch ng resistor only. Then, for I2, since this is since this is a combination of RC circuit, yan, resistor and a capacitor. And so, mapapansin natin, yan, so the current leads the voltage by a certain degree. Yan. Tapos, dito naman sa RL natin, yan, so take note that this is plus. Yan. Ano nun? So, magiging plus yan kasi ito ay X sub L. Yan. So, di ba kasabi nga natin kanina doon sa ating table, naka-plus JXL yon. So, ito naman yung ating I1. So, lagging naman siya or the current lags the voltage by a certain angle dito. So, depending upon kung ano yung impedance natin. So, yan. So, paano natin yun isa-solve yung ating problem if we have that specific dito. If we have this specific circuit. Yan. So, basic type of parallel circuit kapag parallel connection yung pinag-uusapan natin. So, the impedance is somewhat similar to a purely resistive circuit. So, kapag parallel, so the total impedance is equal to the inverse of the summation of the inverse of the individual impedances. Yan. So, all we have to do is to 1 over yung summation ng 1 over Z1 plus 1 over Z2 plus kung ilan man yung impedance connected in parallel. Then, yung total current natin will be the summation of the individual currents for each of the branches, and the total current natin is equal to the total voltage divided by the total resistance, which is equal to the total voltage divided by Z1 or yan. So, yun nga. Yung Z total natin is ito. Yan. So, yung 1 over Z total. So, ito po yung ating gagamiting formula. So, paano naman daw yung behavior ng ating mga other elements? So, kapag ang pinag-uusapan natin is an inductor, ayan, so ang behavior niya will be the same behavior as the resistor. So, kapag ang pinag-uusapan natin ay inductor in series, so that is just the summation of all the inductors, kung ilan man yan. Then, kapag naman inductors in parallel, okay, so that is 1 over L1 plus 1 over L2 plus kung ilan man yang inductors. Then, kapag naman capacitors, o pinag-uusapan natin, yan, kapag capacitors in series, so that is equal to, so kabaliktara naman, so that is 1 over C1 plus 1 over C2 plus kung ilan man yung capacitors in series, sorry. And kapag naman capacitors in parallel, so yan. Ang behavior naman niya is just like a series resistor. Yan. Maliwanag po. Maliwanag po ba yun?
Yes po.
Okay. So yan. So say for example, we have here a 100 microfarad capacitor is connected in parallel with a coil of 10 ohm resistance and 30 ohms reactance. So what is the equivalent impedance assuming that our omega is 377? So paano daw natin ito isosolve? So to solve this, i-drawing muna natin yung ating circuit. So, meron daw tayong 100 microfarads na capacitor. This is 100 microfarads. Connected daw siya in parallel with the coil. So, may coil daw tayo. So, ito yung coil. Ibig sabihin, ito yung combination na ng ng resistance and capacitance. So, this is, pag coil, ang ibig sabihin nun ay combination siya ng resistor and or an inductor. So this is 10 plus J 30 ohms. Okay. So since this is connected in parallel, all we have to do now is to use the formula for parallel impedances. But before that, ano muna kailangan natin gawin? Pwede na ba agad tayo mag-proceed with the parallel or pagsisimplify using parallel connection? Pwede na ba agad? Anyone? Hello? Okay, so i-convert muna natin into microfarads or ohms yung 100 microfarads. So, ibig sabihin, kailangan muna natin kuhanin yung kanyang X sub C or yung equivalent capacitive reactance natin, which is 1 over omega C. Yan. So, 1 over, ang omega natin is 377 multiplied by 100 times 10 to the negative 6. So our capacitive reactance is equivalent to, so we have negative J 26.5252. So yan. So now that we have converted this capacitance into its equivalent capacitive reactance, pwede na tayo may proceed dun sa ating Z total. So, ang ating Z total is equal to, so since ito naman ay dalawa lang na nakaparallel, pwede natin gamitin yung product over sum. Naintindihan po? Yung product over sum. Pero kapag kaya na 3 or more impedances connected in parallel, ay di yung naka-inverse na. Yung 1/1 over Z1 plus 1 over Z2 plus 1 over Z3. So, say for example, so this is negative J 26.5252. So please don't forget to include the negative sign since capacitive reactance yung pinag-uusapan natin. Kasama po yung sign. Multiplied by 10 plus J 30 all over negative J 26.5252 plus 10 plus J 30. So what is our Z total? Kindly compute. Makiki-compute nga po. We have okay, so we have 62.7786 minus J 48.3395 ohms, or in polar form, okay, polar form po, we have so we have 79.2329 bar angle, negative 37.5963 degrees ohms. Okay, so this is now our final answer. Any questions for example A? Any questions? Maliwanag po aring example. Okay, so I hope this one is still clear. Let's proceed with another example. So number 9, a resistor of 50 ohms and an impedance of 100 plus J 50 ohms are connected in parallel across a supply of 220 volts. What is the power factor of the load? Yan. So power factor na ngayon yung hinahanap sa atin. So paano ba natin mahanap yung power factor? Yan. So normally, yung power factor natin ay tinitingnan natin with the impedance of the circuit. So kung ano man yung maging total impedance or the equivalent impedance, dun yung ngayon titingnan kung siya ay leading or lagging. So say for example, we have here our example. Yan. So meron daw tayong circuit. Yan. So parallel ang resistor daw natin and an impedance. So pwedeng ganito ang drawing nyo. Ayan. Pwedeng yan. So ito ay 100, ito ay J50. Yan. 100 ohms, tsaka J50 ohms, tsaka 50 ohms. So connected daw siya to a 220 volts supply. Yan. So, paano daw natin makakuha yung power factor? So, all we have to do now is to get the total impedance. So, the total impedance is, yan. So, we have 50 multiplied by 100 plus J50 all over 50 plus 100 plus J50. So, what is the total impedance? Kindly compute. Okay, so we have 35 plus. Ayan, so 35 plus J5. So, ibig sabihin, yan. So, as you can see here, we have the positive sign of our impedance. So, kung ito-drawing natin siya sa impedance triangle natin, so say for example, ganito. So, di ba, ito yung ating x-axis at ito yung ating y-axis. So, say for example, ito yung 35, tapos ito yung 5. Yan. So, di ba? So, 35, tapos ito, yan. Yan. So, ito yung 5 natin. Tapos, ang ating magiging resultant ay are. Yan. So, ito yung ating magiging z. So, this is 35 and this is 5. And this will be our angle. Yan. Now, so, all we have to do now is to convert this total impedance into its corresponding polar form. So, paki-convert into polar form. So, we have 35.35553 bar angle 8.1301 ohms. Yan. So, now, paano natin kukuhanin yung ating power factor? Ang hinahanap is power factor. Ang power factor natin can be computed which is equal to cosine of theta. So, ano yung theta na yon? Ang theta na ito ay yung angle of the impedance. So, therefore, ang power factor natin dito is cosine of 8.1301 which is equal to we have 0.9899. Then, so ano to? Leading or lagging? So, is this a leading power factor or a lagging power factor? Okay, bakit lagging?
Hindi po greater than 1.
Hindi greater than 1. Hindi naman sadya nagiging greater than 1 ang power factor. Pero ano yung nagiging basis natin kung bakit siya leading or lagging? Positive? Ang alin ang positive? Yung power factor natin will always be positive. Okay. So, di ba sabi ko sa inyo, kapag tinignan natin ang impedance, di ba, ang positive sign here denotes ang ating naging result is parang kumbaga, ito ay naging inductive. So, di ba, lagi ang sabi ko sa inyo last time, kapag naging inductive ang ating impedance or ating total impedance, yan ay lagging. Tapos kapag naman ito ay naging minus, yan ay magiging leading. So kaya ito ay 0.9899 lagging. Yan. Maliwanag po. So, yun lang po ang ating magiging basis. O kaya naman, in terms of angle naman, kapag angle ang pinagbasehan nyo, yung angle ng impedance ay inverse naman yun nung angle ng current. Kasi di ba yun ay ang ano natin, ang current is equal to I RE over Z. So, ibig sabihin, na-inverse yung ating sa current. Kabaligtaran ng angle ng current yung sa impedance. Okay? Maliwanag po ba yun? Okay. So, yan. So, try natin tong isa pang example. A coil of 50 ohms resistance and of 150 millihenry inductance is connected in parallel with a 50 microfarad capacitor. The source voltage is 100 sine 3770 plus 30 degrees. What is the equation of the line current? Yan. So, this one, so i-ano natin siya, i-drawing uli natin. So, this is 100 sine of 3770 plus 30. Yan. Then, connected daw across it are a coil with 50 ohms and 150 millihenry inductor and a capacitor of 50 microfarads. Yan. So, ang hinahanap is the equation of the line current. So, pag sinabi natin line current, yun po ay yung total current. Maliwanag po? Yan. So, paano natin kukuhanin yung ating line current? So, since equation of the line current ang tinatanong sa atin, ang kailangan natin is I of t. Yan. So, saan manggagaling si I of t? Of course, bago natin makuha si I of t, kailangan muna natin kuhanin si I, which is yung ating line current. So, saan galing yun? Ang line current natin is equal to E divided by the total impedance. Yan. So, wherein, ang E natin is equal to, kailangan natin dito is yung ating phasor equivalent ng ating sinusoidal source. So, ano yun? So, that is 100 bar angle 30 degrees. Tama? Tama po ba? Okay, so yan. So ngayon, hindi pa tayo makakapag-proceed agad sa total impedance dahil ang ating impedances ay in terms of inductance and capacitance pa lamang. So mag-convert muna tayo. So para dun sa ating coil, so mag-convert muna tayo. So ang XL natin is equal to omega L, which is equal to, omega natin is 377 times ang L is 150 millihenry. So times 10 to the negative 3. So what is our capacitive reactance? In the compute, so we have J 56.55 ohms. Therefore, ang ating Z1 is equal to 50 plus J 56.55 ohms. Next is capacitive reactance naman. So this is 1 over omega C, which is 1 over 377 multiplied by 50 times 10 to the negative 6, which is equivalent to negative of J 53.0504 ohms. Yan. So therefore, ito na yung ating second impedance kasi wala naman siyang kasamang resistance. Okay? So now, to find the total impedance, we have 50 plus J, 56.55 times negative J, 53.0504 all over 50 plus J, 56.55 minus J, 53.0504, which will give us the total impedance equivalent to so anong equivalent natin? We have 79.8941 bar angle, negative 45.4860 degrees ohms. Yan. Okay. And finally, for our line current, so that is equal to the total voltage, which is 100 bar angle 30 divided by our impedance na 79.8941 bar angle negative 45.4860 degrees, which will give us the line current equivalent to in polar form ng ilagay nyo. Kasi equation naman yung ating hinahanap. Para idediretso na nating conversion. Papuntang equation. So we have 1.2517 bar angle 75.485 or 4860 degrees ampere. So therefore, our line current is equal to 1.2517 sine of 370 plus 75.4860 degrees ampere. So this is now our final answer. Do you follow? Any questions? Okay, so maliwanag tayo dito sa example na are. Okay. Okay. So, ayan. So, that will be all for this example or for this module. So, I will give you sige, 12 minutes break na lang. Balik kayo by 5. Then, ang next topic natin ay yan. Yung last note natin is about power naman. Yan. Okay, so balik tayo by 5 p.m. Nandyan pa ba ang lahat? Okay. So yan. So yung ating topic na sunod is about power naman. So, for our intended learning outcome, so define what is power factor, which is na ano na naman natin last time. Then compute for the real power, apparent power, and reactive power. Then learn formula for susceptance, conductance, and admittance. Yan. So may mga i-introduce tayo ngayon ng mga terms which are not yet been discussed from the previous lesson. So, ano muna natin yung power. So, power, it is customary to refer to an AC load by using the term volt amperes. Yan. In systems involving considerable loads. Representing the product of volts and amperes, it is a measure of such operational factors as current carrying capacity of wires, heating effect in electrical equipment, ratings of machines, and others. So yan. So ibig sabihin, yung power representation daw natin when we are talking about AC circuits or AC loads ay in terms of volt amperes. Yan. So, which is represented by power na S. Yan. So, meron kasi tayong tatlong uri ng power. So, ano yun? Yung tatlong power natin is what we call the apparent power, which is siya yung S. Yan. Apparent power in volt ampere. Yan. Or VA. Tapos, we have the yan, reactive power yan, in volt ampere reactive or VAR at saka yung active or what we call the real power. Yan. Which is measured in watts. Yan. So, ito po yung ating tatlong uri ng power. Yan. So, discuss natin siya further. Yan. So, unlike the situations that exist in DC, where the power and volt amperes are identical, power in AC system can have a number of values from 0 to EI or yung ating power dito. In fact, the well-labeled power factor, cosine theta, terms indicates the extent to which volt amperes become in P or power in watts. So may relationship syempre yung tatlong parameters na yon. So the power factor is an expression of energy efficiency and usually expressed as a percentage, and the lower the percentage, the lesser efficient the power usage is. So ibig sabihin, kailangan daw, 'di ba, yung power factor natin or the cosine theta is ranges from 0 to 1. 0 to 1. So paglapit ng power factor sa unity, pagganda ng ating system. And so, ibig sabihin, lahat ng real power natin ay nakukonsume efficiently at wala yung ibang power na kasama niya. So, the power factor is the ratio of the working power measured in kilowatts to the apparent power measured in kilowatt ampere. And the apparent power is also known as the demand, is the measure of the amount of power used to run machinery and equipment during a certain period. It is found by multiplying the kVA is equal to volt ampere, the result as the kVA units. Yan. So, naulit lang yan. So, type of power factor natin. So, unity power factor, the voltage and current are in phase. So, ibig sabihin, it acts as a purely resistive na load. Yan. And kapag lagging power factor naman, the current lags the voltage by an acute angle theta, which is a series RL or a purely inductive load. Yan, lagging. Di ba sabi ko sa inyo, kapag inductive ang load, lagging. Then kapag leading power factor, the current leads the voltage by an acute angle theta, which is in the case of a series RC or a purely capacitive load. So kapag capacitive, leading naman ang ating power factor. And kapag zero power factor, if the voltage and current are out of phase by exactly 90 degrees, so ideal inductor and ideal capacitor, pero wala naman tayong ideal, so wala tayong zero. Okay. So ito daw yung ating mga formula to find the power. So kapag real power or active power yung ating sinosolve, active or real power measured in watts, so that is equal to EI cosine of theta, which is also the voltage times the current times the power factor. Or E squared over R or I squared over R, tapos P is equal to the square root of S squared minus Q squared. So mamaya ko ipapakita kung anong ibig sabihin na rin S squared minus Q squared square root. Yan. Tapos, kapag reactive power naman, so siya naman ay Q. Yan. So EI sin theta naman ito, then E squared over X. Yan, depende yan kung capacitive or inductive ulit. Then I squared X at saka Q is equal to S squared minus P squared. Then, apparent power measured in VA, S is equal to EI, then E squared over Z, then I squared times Z, then S is equal to P squared plus Q squared. So, take note, ito ay mga ano lang. Yan, ito ay mga magnitude lang ng ating. Yan, kapag ito ang pinag-usapan natin, yan yung naka-square root na yan ay naka-magnitude. Tapos may tinatawag tayong voltage conjugate for solving the value of the apparent power, which is E conjugate times I, saka yung current conjugate, which is EI conjugate naman. So, punta tayo dun sa ating power triangle. Para mas madali nating maintindihan yung power ng AC circuits. So, in-introduce yung tinatawag nating power triangle. So, this is halos same lang ng ating impedance triangle, wherein yung ating x-axis represents the real, true, or active power measured in watts. Tapos yung ating y-axis, yan, represents the reactive power or the Q measured in var. And the hypotenuse of the triangle represents our apparent power or yung ating volt ampere. Then ito po yung ating impedance phase angle. Yan, which is yung atin pa rin theta. So, kapag kinuha natin yan, so itong formula na are is by using the Pythagorean theorem. So, solving for the hypotenuse S, we have S squared is equal to P squared plus Q squared. Take note, ito po ay mga values or yung mga magnitude lamang ng ating mga power. So, ibig sabihin, ang S natin is equal to the square root of P squared plus Q squared. So, kapag ang S is equal to P plus JQ, siya daw ay inductive. So, positive. Yan. Kapag ang S. Kasi ang S natin is the combination of the real power. So, ito yung real power natin. Ito yung real. At ito yung reactive. Yan. So, tapos kapag minus naman are, di ka positive naman siya. As yung cosine power factor is, yan, ang cosine ay adjacent, yan, over hypotenuse. So, adjacent, which is yung P, ang hypotenuse is yung S. Kaya siya ay power or real power divided by S. So, other formulas that can be used to determine the components of complex power is using the voltage conjugate and the current conjugate method. So, ito po yung ating power triangle. Yan. So, by voltage conjugate, ito daw yung magiging natin, kapag ang S is equal to E conjugate I, So, ang S natin is magiging P plus minus JQ kapag ang Q natin is positive, leading ang power factor. So, mababaliktad. Di ba? Anong last time natin din eh? Kapag ang positive, di ba, ang positive, ibig sabihin, laging yon. Pagka ang ginamit natin ay E conjugate I or the voltage conjugate. So, ito ay in terms of S ha. Kapag ang S natin, ang naging result, kapag pinag-multiply natin yung voltage at saka yung current, ay naging positive, yan. So, leading daw yon. Kapag ka naman Q ay negative, lagging yon. Tapos, kapag kakabaliktad naman yung current conjugate naman, kapag ang Q natin ay naging positive, yun ay lagging. Kapag ang Q ay nag-negative, yun ay leading. Ang malimit kong ginagamit ay aring current conjugate kasi ito din yung nagiging parang kumbaga katulad nung ating naging notation last time na kapag positive, di ba, yung sa impedance, kapag positive siya, yung X natin kapag positive, 'di ba, laging 'yon. Tapos kapag ka naman ang X natin ay negative, leading 'yon. So parehas lang siya nitong in terms of Q. So kaya mas malimit yung ginagamit kapag ka ang pinag-uusapan natin is yung apparent power, yan ay kumbaga ito ay yung kaparehas nung sa impedance. So, hindi ako masyadong malilito kasi parehas lang sila. Kung positive are, laging yun. Kung negative yun, leading yun. Okay pa? Maliwanag po ba yon? Any reaction?
Yes po.
Okay. So, yan. So, para mas madali yung maintindihan, para sa mga mag-iinom, so ito yung representation natin ng power. Kapag inihambing natin ang power, yan. So, ano bang ibig sabihin yung mga, ano yan, yung mga aparing, yan, mga gayaan. So, ari lang yon. Wait lang. Ba't ayaw niya makopy? Copy. Hello, ayaw. Bakit ayaw mag-paste? Ayaw na mag-paste doon sa ating. Siguro dahil ano na, puno na. Sige, wait lang. I-share ko na lang sa inyo, aring. So, ano daw pinagkaiba niyang tatlong yan? So, ari daw yun. So, kapag pinag-usapan natin ng power yan, pwede natin siyang ihambing sa isang beer. Yan. So, yung tatlong power natin, yung real power, yung reactive power, at saka yung apparent power. Yan. So, anong ibig kong sabihin? Kapag daw yung real power natin, ito daw yung usable na energy. Kasi yan yung real power nga. Yan. Ito lang yung nagagamit. Yung reactive power, yan yung bula-bula ng beer na hindi naman natin, or hindi naman na-enjoy ng nainom. Kasi hindi ako nainom ng beer. Yan. So, reactive power, yun daw yung tinatawag nating wasted energy or electricity. So, ibig sabihin, pagtaas ng reactive power, pagbaba din ng magiging real power natin. Kasi di ba hinahati lang naman yan. So, ibig sabihin, hindi efficient yung ating, so hindi efficient. Yan. So, yun ang ibig sabihin nun. So, dapat, ang mangyari is mapababa natin yung reactive power na yan para kakaunti yung wasted electricity natin. Tapos, yung total nila, yan, edi yun yung ating apparent power. Maliwanag po. So, ibig sabihin, ang kailangan lang talaga natin is yung real power. Okay, so yan. Na-share ko lang naman para mas madali nyo ma-visualize kung Ano ba ang ibig sabihin niyang mga yan? Okay. Yan. So, kapag pinag-usapan natin yung mga circuit natin, kapag RL circuit, yan. So, ang resistance, so kapag iginrap natin yan sa ating coordinate system, so ito po yung real power. Laging nasa x-axis ang ating real power. Yan. Tapos, ang L natin, ang Q niya is pababa. Yan. Yan. Ito yung Q. Tapos, ang S natin ay R. Yan. So, ang ating S ay ito. Tapos, ang angle natin is ito. So, di ba pag ganitong ikot niya, kaya siya ay lagging. Tama. Yan. So, kung kukuhanin natin ito, itong mga to, ito yung mga magnitude lang ha. Yan, magnitude lang yan. So, kung gagamitin natin ang P, so, di ba ito yung nasa adjacent. So, in terms of Q and S, yan. So, ang power natin, yan. So, kung ang pagbabasehan natin is EI yan, EI cosine theta. Oo nga. Tapos, ang Q natin is EI sin theta. Ang S natin is EI. Tapos, ang power factor natin is P over S. Yan. So, yan yung sa RL circuit. Kapag ka naman RC circuit, edi kabaligtaran nun. Yan, ang nasa x-axis pa din natin ay yung real power natin. Ang Q natin ay nandidini pa rin. So, pataas na siya ngayon. Tapos, ang S natin ay R. Yan. Tapos, ito pa rin yung ating theta. So, ganun pa rin. EI cosine theta for the power. Tapos, ang Q natin is EI sin theta. Ang S is EI. Ang power factor is ganun din. So, kapag inductive load, RL, yan. So, ang power total daw natin is P1 plus P2. Ang Q total is Q1 plus Q2. Tapos, ang S total is equal to the square root of PT squared plus QT squared. Or ang power factor natin is the total real power divided by the total impedance. Or total volt ampere na power. So, hindi na natin masyado yung pag-aano. So, ito naman, yung mga diagram na hindi na naman natin yan masyado pagtutuunan ng pansin. Ano? Yan. So, ito yung sa mga power factor correction. Yan, halimbawa, meron kang RL, tapos dadagdagan mo siya ng inductive na circuit. Yan. So, ibig sabihin, madadagdagan yun. Halimbawa, sige, discuss na rin natin para sabihin na naman. Yan. So, halimbawa, dalawang RL circuit yung ating dinagdag or so, ang magiging baba to, di ba? Resistance. Yan. So, kapag resistance, so, di ba, is P1, ang S1 is equal to P1 plus JQ1. Tapos, ang S2 is equal to P2 plus JQ2. Yan. So, ang unang muna natin ano dyan is yung unang ito. So, kapag i-graph natin yan, so, ito yung unang part. So, halimbawa, ito yung P1 natin. Tapos, yung Q, bababa, di ba? Yan, bababa siya. So, ito yung Q1. Tapos, dito, yung component method, so, ito dapat yung unang S. Yan. Pero, may madadagdag pa. So, dadagdagan natin yan din ng isa pang P. So, this is P2. Tsaka, bababa yung isang Q2. Yan. Tapos, ay di yung component method lang. Ito din yon. Yan. Yan din po yun. Yan. So, ito yung Q1, ito yung Q2. Basta parang i-add mo lang siya. Yan.
Magpa-pray lang ako.
Okay, so yan. Tapos, kapag ka naman, kapag inductive lang, kapag inductive load, RL. Yan. So, P1, P2, tapos Q total ulit. Yan, ito. Tapos yun. Tapos, kapag RL, yan, kapag dinagdagan mo ng isa pang L, edi retain yung ating original na P, kasi P1 lang naman yun. Diba? S is equal to P1 plus JQ1. Tapos dahil L circuit lang yan, ay Q2 Yan, kaya pagka punta din ng power, ng real power, bababa siya ng Q1, tapos mag-a-add ka ng Q2. Yan. So, yung total Q. Yan, Q total. Yan. Tapos, ito ngayon yung kanyang, yung kanyang, S total. Yan. So, parang ina-add lang naman yan. I-add mo lang naman siya. Okay? So, para mas maintindihan nyo, ayan, i-ano natin itong example na array. So, an AC circuit load is rated 160 kilovolt ampere at a lagging power factor of 0.75. Determine the real and reactive powers. Ayan. So, paano natin ito isa-solve? So, para ma-solve natin yan, ang unang-unang mong titingnan is yung power factor niya. So, di ba sabi laging power factor daw? So, kung laging power factor yan, kung i-drawing natin siya, saan ang gana niya? Pataas o pababa ng triangle natin? Laging power factor daw. Kung nakinig kayo kanina doon sa diniscuss ko. Pataas o pababa? Kung i-drawing natin yung power triangle. Laging power factor. Ano yun? Nasaan siya? Ano ba pag laging? Bakit pataas? Pag laging ang power factor ng circuit, anong ating involved doon na reactive power? Inductive or capacitive? Balikan natin. So, diba dito sa power triangle natin, anong sinabi ko kanina din eh? Anong angle na to? So, diba yun ay inductive. Ibig sabihin, pababa. So, kung i-drawing natin yung power triangle natin, dito yung real power. Ito yung P. Tapos, ito yung Q. Pababa. Tapos, ito yung aking S. Yan. So, ngayon, ang sabi daw, ay laging power factor daw. Laging power factor. So, since power factor ang given, so, which is cosine of theta is equal to 0.75, ang kailangan natin makuha is yung angle. So, to find the angle, we just inverse cosine yung 0.75. So, ano yung magiging angle natin? So what is the value of our angle? Paki-compute. So we have 41.4096 degrees. Okay. Now, so ito na yung angle natin. So paano doon natin makukuha yung real? So pag sinabi nating real power, so that is P. Yan. So in terms of the triangle, ano yung may value na natin? Ang may value natin is yung S at saka yung angle. So anong identity ang pwede natin gamitin para dito? Sige nga, paano natin isosolve yung real power na P in terms of S and angle? So in terms of the triangle, ano yung P? Di ba meron tayong opposite, adjacent, and hypotenuse? Ano yung P? Adjacent. How about S? Hypotenuse. So, with respect to the angle, anong identity ang involved ang adjacent and hypotenuse? Anong trigonometric identity? Okay, so cosine. So, di ba sabi natin, ang cosine of theta is equal to the opposite, adjacent over hypotenuse. So, which is yung adjacent natin is yung real power at yung hypotenuse natin is S. Therefore, ang P natin is equal to S cosine of theta, which is 160 times 10 raised to 3 volt ampere multiplied by cosine of 41.4096. So our power is equivalent to ano magiging value ng ating real power? So anong value ng real power natin? So 120,000.0408 or simply 120 kilowatts. Nakuha po. Nakuha po yon. Any questions? Okay, so how about naman yung ating Q? So in terms of Q naman, so Q is equal to, so kung ang pagbabasehan pa rin natin is yung original natin na S at saka Q, ano namang trigonometric identity ang ating gagamitin? So ano yung involved ang Q at S? So now ang Q natin is the opposite. So ano ang trigonometric identity na merong opposite at saka hypotenuse? Okay, so we have sine. So we have sine theta is equal to opposite over hypotenuse, which is Q over S. Therefore, ang Q natin is equal to S sine of theta. So substituting the value, so we have 160 multiplied by sine of 41.4096 degrees. So therefore, the apparent power is equivalent to, I compute, 105,830.0061. So this is VAR or VAR. Volt ampere reactive or 105.830 kilo VAR. Yan. Yan. So therefore, ang ating S, kung isusulat natin, ang S natin is equal to P plus JQ. So that is 120,000 plus J or 120 na lang plus J 105.830 kilovolt ampere. So, yan. So, ito po yung ating complex formula ng ating yan. So, ating apparent power. Okay? Any questions? Naintindihan po ba yung sa ating power? Naintindihan po ba? Sagot naman kayo. Okay. So, pakitry nga muna nito. So, a 50 microfarad capacitor is connected in series with a 50 ohm resistor. What is the power if the source voltage is V is equal to 100 sine 377 plus 30 degrees? Sige, tatry muna natin na bago ako magbigay ng isang example na kayo naman magsasolve. So, try muna natin ito. So, meron daw tayong given na circuit, series circuit, connected to a source na 100 sine of 307.70 plus 30 degrees volts. Tapos meron daw tayong 50 microfarad capacitor connected in series with a 50 ohm resistor. So 50 ohms, tapos ito ay 50 microfarads. So tinatanong sa atin is the power of the source voltage. So since power of the source voltage yung hinahanap sa atin diyan, walang specific, pero ang gagamitin natin is yung real power. So, paano natin kukuhanin yon? So, all we have to do, so maraming paraan kung paano natin makukuha yung power. So, kung ang pinag-uusapan natin is apparent power, so S, yan, this is the complex form of our power. Pero pag ang pinag-uusapan naman natin is yung power, which is yung P, so sabi nga, ang real power ay matatagpuan lamang yon dun sa ating resistor. Yan, so sa resistor lang yon. So, simulan muna natin dun sa ating pag-compute. But before we compute, kailangan muna natin makuha yung impedance natin. So, ang Z natin is equal to R minus JXC. Kasi capacitor yan, so minus JX yung ating um, value. So, kuhanin muna natin yung ating X sub C. So, this is 1 over omega C, which is 1 over 377 times 50 times 10 to the negative 6. So what is our capacitive reactance? Compute. So we have 53.0504 ohms. So therefore, ang ating impedance is equal to R, which is 50 minus J, 53.0504 ohms. Now, so paano natin kukuhanin yung ating, say for example, dito na lang tayo kumuha sa S. Ang S natin can be computed, kagaya ng sinabi natin kanina, using two formulas. So, meron tayong tinatawag na voltage conjugate at saka current conjugate. And sabi ko sa inyo kanina, mas sanay ako dun sa current conjugate. Yan. So, kung current conjugate ang gagamitin natin, of course, kailangan natin ng current. Yan. So, di ba, yun ay magiging EI conjugate. So, kailangan muna natin kuhanin yung current. So, para makuha natin yung current, that is E over Z. Where E natin is the phasor form of our source. So, this is 100 para angle 30 divided by 50 minus J 53.0504. So, what is the value of our current? Recompute nga. We have, so anong value ng ating current? So we have 0.3175 plus J 1.3350 amperes. Yan. So ito daw ngayon yung ating current. O anong tunay? 3350 or 3349, okay lang yan. Now, so gagamitin natin ngayon itong formula ng ating apparent power. So to solve for the apparent power, and so that is EI conjugate. So pag kina-conjugate natin, ang iniiba lang natin is yung sign ng ating tawag dito, nung ating imaginary component, o kaya naman kung angle ang pinag-anuhan natin, edi i-negate lang natin yung angle or babalik rin natin yung kanyang sign. So in this case, so ano yung in natin? So this is 100 para angle 30 multiplied by the conjugate, so 0.3175 dahil array plus, so magiging minus yan, minus J 1.3350. So our S is equivalent to so ang sagot natin. Yan. So we have 94.2463 minus J 99.7394 volt ampere. So yan po yung ating sagot. Now, ang hinahanap natin is yung real power. So what is now our, yan. So tama po ba yung ating mga conversion? 3.05. Tama naman ano. So we have 50 minus 55 point, 53.0504 I 72.89. Okay. So, kung hindi tayo magra-round off dapat dyan, supposedly, ano yung magiging sagot natin? So, kung hindi tayo magra-round off, so, di ba, yung 1 over 377 times 50 negative 6 negative 6. So we have 100 or angle 30 over 50 minus ating impedance. And tapos 30 is conjugate of the answer. Yan. So, dapat, ang laki ng discrepancy pala. Medyo malaki yung naging discrepancy natin. Supposedly, ang magiging sagot natin ay 94.085 minus J 99.8249 volt ampere. Yan, ito ay no round off. Yan. No round off in the, or no rounding off dun sa middle of our solutions. Yan. So, bakit? Tingnan natin. So, pwede kasi, ang gamitin lang natin is yung kapag ito kasi, ito na yung real power. Ito na yung P, ito na yung Q. Tapos, ito ay capacitive. Yan. So, ibig sabihin, ang real power natin is 94.0850 watts. Yan. Yan ang dapat yung sagot. Ngayon, para makuha natin yun, may isa pa tayong way. So, di ba yung current natin, yan. So, pwede kasi na yung kuhanin natin is in terms of the current. So, halimbawa, ang power, kasi real yan, pwede siyang gawing I squared times R. Di ba? Yan, I squared times R. Para makuha natin yung current is kukuhanin natin yung kanyang value doon sa magnitude ng ating voltage source divided by the impedance. So, that is E over the magnitude of Z. Yan. So, paano natin kukuhanin yung Z? So, yung magnitude ng Z natin is, alin? So, yun, di ba yun yung square root of R squared plus XC squared. So, this is the square root of R, which is 50 squared plus negative 53.0504 squared. So, anong value ng z natin? Tingnan nyo nga. Tapos, huwag tayo magra-round off, ha? Huwag muna tayo magra-round off. Bago pala, ito ay yung buo din. Huwag yung i-round off din. Yung 1 over 377 times 50 exponent of negative 6. Yan. So, dapat siya ay 53.039788. Yan. 05039788 square. Wait lang. Okay. So, yan. Anong sagot natin dyan? 72.89955223 ohms. Yan. Ito yung magnitude ng ating impedance. Yan. So, kung isa-substitute natin siya dito, so ito ay 100 na lang kasi yan yung magnitude divided by 72.89955223. So, ano magiging sagot natin sa Karen? So, we have 1.371750538 amperes. Yan. Tapos kung gagamitin natin siya by using the formula of power, so power natin is I squared, so 1.371750538 squared multiplied by 50. So, yung power natin is equivalent to so we have 98.08497695 watts or 98.0850 watts, which is the same as ito. Yan. So, wag lang muna tayong mag-round off. Pwede namang i-shift store or i-store dun sa inyong mga calculator yung values natin. Okay? Shift store, tapos pili lang kayo dun sa A, B, C, D, E, F, tsaka dun sa X, Y. Wag lang dun sa M. Yan, makikita nyo naman yan sa inyong calculator. Okay? Maliwanag po. Okay po tayo doon. Okay. So, try nyo nga itong isang example. Yan. So, a load of 20 plus J35 is connected across a 220 volt source. Determine the reactive power. Yan. Reactive power ang tinatanong. Reactive power or Q. Try nyo nga. Ano yung 938.4615? So, 1032.3077. Sige, tingnan natin. How about the others?
Kung saan, tawag natin, sinabi natin na dapat M, which is our maximum.
Okay, so ito, may kinonfirm lang kami about dun sa naging solution natin. So, ito, kindly take note of this ha. Kasi this is important. Yan. So, kapag ganito, so di ba yung kapag ang given natin na voltage ay in this form, so di ba yan ay Vm, say for example, sine omega t plus a certain angle. So di ba ito ay naka-maximum na. Yan. So wala tayong problema kapag nag-substitute tayo ng ating value. But if we are going to use or to give emphasis to problems with ganitong value. Say for example, 220 volts. So, ito po ay naka RMS value pa. Yan. So, ibig sabihin, kung babalikan natin yung discussion natin, ang part 1. So, di ba, inaral natin yung, ayan, instantaneous, average, yan, peak factor, form factor, tsaka yung RMS. Yan. So, kapag inano natin yun, so, di ba, maximum yon. So, ang RMS value natin, ang RMS value is equal to the maximum value over square root of 2. So, para makuha natin yung maximum value, di ba yan ay square root of 2 multiplied by the RMS value. So, kung babalikan natin yung ating given, yan, dito. So, let's go to problem number 2. Number 1, katulad nito. Yan, so di ba Karen? Ibig sabihin, kailangan muna nating i-convert itong volume ito into its equivalent RMS. Pakibalikan nga, ano yung naging sagot natin dito? Sa example number 1. Pakitingnan niya. Ano naging sagot natin dyan? Sige, solve na lang natin. So, di ba, ang ginawa natin dito is kumuha lang tayo ng value. At idinirekta natin yung I natin is equal to 220 over Z, which is yung nakuha nating magnitude, which is 40 or 55 rather. Yan. So, ang nakuha natin current dito ay 4 amperes. Supposedly, if we're going to solve this, halimbawa, kung gagamitin natin yung sa form, kailangan, so 'di ba ito ay naka-instant RMS. So ang ating VRMS is equal to 220 volts. Para ma-convert natin yan into V maximum, that is equal to 220 square root of 2. Yan, volts. Ito dapat yung ilalagay natin. So in that case, in order to solve for the current, that is V over R, or in this case, Z na. So, V over Z. Yan. So, ang Z natin ay 40 or R plus JXL. Yan. So, we have here, ang XL natin is 377 times 100 millihenry. So, ano yon? Anong XL natin dito? Okay, compute mo. So, 37.7 ohms. So, therefore, ang ating impedance is equal to 40 plus J 37.7 ohms. So, kung ilalagay natin siya dito, so that is 220 square root of 2 over 40 plus J 37.7. So, ang current natin dyan, supposedly ay 220 square root of 2 over 40 plus 37.7. So, we have 5.6603 bar angle negative 43.3045 degrees ampere. So, therefore, ang ating maximum value, so kung ilalagay natin siya sa equation form, ang I of t natin is equal to 5.6603 sine of 370 minus 43.3045 degrees ampere. So, ito dapat yung ating magiging sagot. Wherein, ang ating Imax is equal to 5.6603 amperes. Yan. So, supposedly yan ang sagot. Nakuha po. So, unless otherwise stated na ito ay maximum value, kapag mga ganito lang ang given, yung mga walang angle or hindi naka-instantaneous format, yung hindi naka-phasor, so yun ay assume natin na lagi siyang RMS value. At i-convert pa natin siya papuntang maximum value. Maliwanag po? Am I clear? O wala na nakikinig sa akin? Okay, 1, 2, 3, 4, 5, 6, 7, 8, siyam, 10, 11. Okay. So yan. So kindly go back to our previous problems. Tapos pakitingnan kung hindi natin nagawa yung pag-multiply. So halimbawa dito, 'di ba ari ay ang naging sagot natin sa problem number 2 ay 2.84 amperes yung naging sagot natin diyan. So supposedly ang magiging sagot natin diyan ay i-compute natin siya 2.84. So magiging sagot natin diyan dapat ay magiging 4.0164 amperes. So, bakit? So, kapag kinompute natin yun, so ang x sub c natin ay 1 over 377 times 40 times 10 to the negative 6. So, ang x sub c natin dyan ay 53.05 ohms. Yan. So, ang magiging current natin is equal to 220 square root of 2 over 40 minus j 53.05. So, that is 220 square root of 2 over 40 minus 53.05 I. So, medyo malaki yung discrepancy niya. Yan muna natin. Check natin ha. 1 over 377 times 40 negative 6. Mali pala. 66 point something pala yung ang XC. Mali pala. 66.313. Yan. So, magiging 220. So, this is 66.313. Square root of 2 over 40 minus answer. Yan. So, dapat ay magiging 4.0175 bar angle 58.9016 degrees ampere. Yan. Or, ang I of t natin is 4.0175 sine of 377t plus 58.9016 degrees ampere. So, ang maximum natin is equal to 4.0175 amperes. Okay? Maliwanag po. So, kindly go back with the problems involving such example or yung mga values na ganyan. Tapos, paki-resolve ha. Tingnan natin kung ano yung magiging value. Okay? Yan. So again, unless otherwise stated na yun ay maximum value na, we will assume that yun ay RMS value. But if In case na siya ay naka-equation form, wala na po tayong babaguhin doon. Yan. So, wala na tayong babaguhin doon. Yun ay naka-maximum na po. Halimbawa, kung ang given natin ay ang v of t or ang ating given ay 100 or 200 sine omega t plus 30 degrees volts. So, pag sinubstitute nyo yan doon sa ating formula, di yan ay 200 bar angle 30 na agad. So, maximum na ito. Yan. So, ang makukuha mo na din na value ay di naka-maximum na din yun. Ano? Over yung impedance, whatever impedance is given. Yan. Okay? So, yun ay, ano lang ha, clarification lamang.
nakuha ang sagot. Either siya ay
Okay, so, I think yun lang muna. Then, tuloy natin yung discussion by Sunday. Okay? Siya, sige, yun lang muna.
Bali po kasi